This is an investigation into image formed by a convex lens, and we're going to have a candle, a lens of f equals 15 centimeters, and a screen, and we can measure these distances u and v. And how does changing u affect the position of the focused image on the screen v, and how does it affect the magnification of the image, whether it's upright or inverted? We can calculate the magnification using height of image over height of object. I over O, we measure the flame. Example there given. So the apparatus that we're going to use looks like this: a lens mounted in a holder, a meter rule, a screen, a candle, and the table, the results, looks like this. We've got the distance between the lens and the object, the candle, and the distance here between the focused image and the lens, v. And is a focused image formed, yes or no? Is it upright or inverted? Is it magnified or diminished? Is it real or virtual? Of course, if we see a focused image on a screen, it must be a real image. Then we actually measure the height of the flame, which should stay roughly the same, that's the object, and the height of the image on the screen, and then we can work out the actual magnification from that. So that's what we're going to proceed to do now. But first of all, the lights need to go out, and then once the lights are out, we need to light the candle. So light the candle, and then magic, out goes the match. So now comes the part where we're going to follow what's on here. The first distance is 22.5. So we're going to move this to 22.5 on there, and that's about here. So that's u, 22.5, and then we're going to move the screen. It's blurred now. There, I think it was just there when it's nice and in focus. You can see candle flickers, you can see the image on the screen is flickering as well, but it's clearly inverted. And now we need the distance from the lens, line it up nicely, to the screen, and you might just be able to see that distance there. And what I'm going to do is light that up, lamps, you can see, and you can record that distance there. Okay, there it is. So we also need the height, and that's tricky, but I'm going to use this compass as a calipers and move the pair of compasses to roughly get that height there. And the height is going to be from 0 there, and you can see, you can record what you think that distance is right there. Okay, so the next one we're going to do is for a distance of, it says 7.5. That's half f. The previous one was 1.5 f, so 7.5. Right, line up 7.5. It is actually correct there. And now, again, we're going to move this screen. Nothing there. there, as far as you want. There doesn't appear to be an image forming, so that's a cross there, isn't it, for no image formed. The next one is 15. Now that's equal to F, so I can move this to exactly 15, quite exactly. And then again, what do we get? No, there's something there. It's like a very large, blurry image, but it's not focusing, which is interesting, isn't it? You can find out why that's not the case. So F at U equals F, we don't get an image. The next one is 20. Move that to 20. On it goes. There we go. That's at 20, I think. Now, and there's an image right there. I think that's hard to tell when it's exactly focused, but I think it's about there. And I'm going to measure that. So make that right on the middle of the lens. And here, what have we got now? Hopefully you can see where that is. There you go. And the height, again, tricky little measurement here, but we use our calipers. We're getting now quite close to what it was before, really. And there. See that? And now the next one is 30. So I move this to 30 and find, now I'm coming in and it's just about there. So now I measure that distance V, and V there we are. Height of the flame, the image height. Oh, now it's much smaller. And we get see what that's on. Okay, between 1 and 2, isn't it? And the next one, 40. And that's going to move along to 40. What happens now to the image? Bring it further in? No. Out a bit. There. It's very small now. It's clearly diminished now. And that distance from the lens to the screen is like, here we are. Take that reading. And the height of that, again, close them up a bit, perhaps about that. It's a bit smaller than it was before, and let's put it on the 10. It focuses a bit better. How many millimeters have we got there? So from there. There we are. And then finally, we have a distance, no, not finally, there's two more, 50. That's on 50 now. And what's our image do? Where do we go? That way. It's really tiny now. Really tiny. And the distance V is there we are. The height, I'm quite small now. And let's put it on the 10. Well, how many millimeters is that? Estimate it. And now it's the final one. We want this to be 60. There we are. And where's the flame now? The image is right there, I think. And that distance is there we are. And the height, getting really teeny now. It's only slightly smaller. It's really small. Very diminished. And on our millimeter scale, there we are. Estimate how many millimeters that is. Again, it's not be terribly accurate, is it? So there we have your results table should be filled in. You can use those values to get the magnification. Don't forget the flame height that we put down at the start. Did we put down the flame height? If we didn't, let's measure it now. Because we're going to need that. So for this one, I'm going to get the calipers and get right down to the right level. And it's looking like the flame height is, let's start from 10 again. That's how many millimeters we've got for the flame height, which is the object, of course. Okay, so use my help there. That looks like that's about 13 millimeters. So now we can process those results, get magnification for all of those, well, the ones where we found an image. And as a piece of extension, this is the thin lens formula. And this, you can investigate, does this apply? If you put your value in for U, for each one, each distance of U, then put the corresponding value of V, and then if that's always going to be 1 over 15 centimeters, these have to be in centimeters, all in centimeters, or all in meters, or all in millimeters. As long as it's the same unit, then you should see whether our results are any good. So that's the investigation of the image formed by a convex lens.